Very good morning, good afternoon, good evening, my dear friends, wherever you are. Welcome back to this 7th lecture in Total Quality Management. As you know, I am Raghunandan Sengupta from the IME department, IIT Kanpur. And this course of Total Quality Management, which is of 20 hours and 40 lectures, each of half an hour. So, as you know that in the fag end of the 6th lecture, we were discussing about probability distribution functions, probability mass functions, density functions, and how normal distribution, I did stress on normal distribution, how it will be utilized, and we will come into the details more later on. So, let us start with full energy, the 7th lecture. So, if you remember, we were discussing about probability mass functions. Mass, why the word is, because number 1, the x are discrete, and if you remember, I did mention two very distinct examples, one being when you are basically tossing a coin or when you are rolling a die. So, the die are all faces can come up unbiased, numbers are marked 1 to 6 or A, B, C, D, whatever it is, and the coin has a head or a tail or a black and white color, based on that which you can do the experiment. And continuous can be where x is continuous within a range, and for the normal distribution it is from minus infinity to plus infinity. Other examples which can be considered as continuous for x being measuring the height, measuring the length of a tie rod, and such examples. Now, another thing why it is mass function, because the x discrete values are such that the probabilities are concentrated at those points. So, it is basically known as probability mass function. So, I have this in the left panel in the slide, I have basically the probability mass function. It looks like a normal distribution, as it should be, the histogram is a normal distribution. And if I add up all the probabilities, because we all know, I will just highlight it very simply, that the CDF value which I am writing is equal to, in the case if it is a discrete value, it will be the sum of all of f of x. F of x means the probability mass function, and the CDF, and this would basically be for all x being less than equal to some x star, based on which you want to find out the CDF value. And in case if it is a continuous one, it will be integrated from minus infinity, considering this is the minimum value of x, till the value of x star, wherever you want to find out the CDF f of x dx. So, this is the probability density function, and then based on that you find out the CDF values. So, on the right panel we have basically the corresponding CDF of the probability mass functions, and if you notice, it is basically sum of all the probabilities as you proceed from the left to the right. Left means the minus infinity value or the least value for the probability mass function. So, now if we come to the case of the normal distribution, which we will be utilizing quite rigorously. So, you have the x value, z values. If you remember, I did mention that for all the discussion of the normal distribution, we will be considering the standard normal deviate, for which the mean, median, mode values are all 0, standard deviation or variance is basically 1, and based on that we will see that we have the tables such that we can do the calculations accordingly. So, here in the top figure, which is the normal distribution PDF, we have the z values along the x axis and the corresponding probabilities being measured along the y axis. So, this is the distribution which you have, where I am basically hovering my this pointer. Now, you may see the values decrease exponentially onto the left and decrease exponentially onto the right, but technically the values should be between minus infinity to plus infinity. Now, if I have the corresponding CDF value for this f of z means the standard normal deviate which I have for the normal distribution. So, this is basically capital F of z. So, then in that case the CDF value is given, which also would be utilized later on for our calculation. I am just giving you a feel that how the distribution from the normal case looks like, the PDF value and the CDF value, so that you can understand how we can utilize the tables in order to do our calculations. So, here as I mentioned, this is the table which is the standard normal distribution in the standard normal table, which is the cumulative one. Remember why it is cumulative one, I will come within another 1 minute. So, this is the normal distribution with, if you remember, I did mention quite few number of times in the last class also, which is the 6th lecture, and today also few minutes back. The mean value mu of z is 0, that be because why, z is the random variable, while the standard deviation for z, the standard normal deviate is basically 1, and this is termed as the standard normal distribution. So, if you look at the table and also with respect to the diagram which has been drawn here. So, this diagram shows some light shaded portion till a value of z where my pointer is, and the portions onto the right of z is basically white in color. Why it is that, I am going to come within few seconds. So, the first column of z are the standard normal deviates realized values, and the values inside are basically the CDF value. So, I will highlight one point which will make it very clear to you. Now, if you consider the z value at 0, so if and also if you consider the overall sum of the probabilities or which is the CDF of the standard normal distribution or any distribution from its minimum value to the maximum value, then the overall area inside or underneath the curve is 1. Now, as mean, median, mode, for the case for the normal distribution is equally distributing or dividing the normal distribution in 2 equal halves. So, if it is 0.5 and if you basically pay attention to the value which I am circling, it means that for all the sum of the probabilities starting from minus infinity to 0. So, hence the shaded region means when z is basically at 0, the overall area from minus infinity till 0 is equal to 0.5 as it should be, and this is the value which is denoted here. Now, similarly, say for example, if I want to find out the value of the CDF value from minus infinity to say for example 0.3, so then in that case the overall area is basically 0.61791. In case if I want to find out the overall CDF value for minus infinity to say for example 1.3, then in that value the case the is the CDF value is 0.90320, and in case if I want to find out the value of the CDF value from minus infinity to say for example 1.404, so in that case the overall the CDF value is where I am circling, which is 0.92506. Now, remember one thing, as the normal distribution or standard normal distribution equally equal to both to the left side of 0 and right hand side of 0 because it is symmetric. So, hence if I want to find out the value of the CDF value starting from say for example minus infinity to minus 0.8, in that case minus 0.8 would be somewhere to the left. So, what I would do is basically I would find out the value from say for example 0 to 0.8, which would be on the right hand side. Now, 0 to 0.8 would be about 0.78814. Overall area inside the curve is 1. So, 1 minus 0.78814 would give me the area onto the right. That means, starting from any value greater than 0.8 till plus infinity. So, as it is symmetric, that value would be coming onto the left hand side. Hence, the overall CDF value from minus infinity to value of minus 0.8 would be 1 minus 0.78814. So, you could utilize this table which is given here in order to do all the calculation for the normal distribution and the standard normal distribution. So, coming to this, the 6 sigma concept, I will be very brief in this discussion because we will be encountering and coming to the concept of 6 sigma later on also. So, it was developed by Motorola in the 1980s, and it basically focuses on reducing the variability of the product quality characteristics, whatever the quality is. Say for example, it may be micron thickness of the paint, it can be say for example length of the tie rod, it can be say for example weight of any particular product which you are manufacturing, it can be say for example the level of noise the overall machine produces, whatever it is, the characteristic is based on which we are trying to study how good or the bad the machine is, or how good or bad the services are. It can be translated in the cases of service sector also, based on the fact there is some quality level, quality characteristics assigned to that metric which you want to measure using the concept of Six Sigma and the corresponding concept of standard normal deviate. So, again continuing where we just left. So, Six Sigma basically focuses on reducing variability of product quality characteristics to a level at which defects become extremely unlikely, because if you are able to reduce the risk, obviously the per percentage or per million or per thousand number of defects obviously would reduce, which would mean that the amount of variability with respect to the good items being there would obviously increase. I am basically using the negative connotation, in the sense if it is if the quality is improving, it means the overall variability of good products would increase. On the other hand, if quality is being good, the manufactured goods or the services are good, obviously it would mean the variability for the bad products is basically decreasing. That means there is very less likelihood or less chances of a bad product coming. So, continuing the discussion, we assume that a particular quality characteristics, whatever it is as I mentioned, follows basically a normal distribution with certain mean mu and a standard deviation sigma. So, if there is a mean mu and standard deviation sigma, obviously we can convert that case into the standard normal deviate, where the mean now becomes 0 and the standard deviation becomes 1. So, in this case, if I have been able to convert the concept of the characteristics of any quality metric which you are going to measure from the normal distribution to the standard normal distribution case, and basically try to implement or bring the concept of Six Sigma, then the graph would look as it is shown in this slide, where as you can understand the middle value would be the mean, median on the mode, which is of value 0, and on the left hand side and the right hand side you will basically go as per the concept minus 3 sigma onto the left from my side. So, basically you are going towards minus infinity and plus 3 sigma onto the right, which means you are going towards plus infinity, such that the overall length of dispersion which you are trying to consider from 0 onto the left and the right, the total length would be 3 sigma onto the left, 3 sigma onto the right. So, the overall length is basically 6 sigma, hence it is basically concept of 6 sigma. So, if you consider the overall characteristics, then it becomes very simple that how you are going to basically find out the level of defect or level of percentage of good products which you are going to consider. Now, with this, let us refer to the table which was shown, and I will strongly urge all the participants, all the students who are trying to basically do this course, at least pick up the standard normal table and its corresponding distribution, how it looks like, keep it with you as we progress along with the course, because that will give you a lot of information. Now, if you refer to the table, then it, and if you want to find out the level of, say for example, confidence which you have, corresponding to the fact that if you move minus 1 sigma onto the left and plus 1 sigma onto the right, then the overall percentage specification within that bandwidth, which means the overall area between the bandwidth of mu minus sigma till mu plus sigma, the overall coverage of area is 68.27, which means that any product which is falling within that bandwidth is good. And if I basically continue doing my experiment, then out of 100 about 68.27 percentage of those good items would be in that bandwidth, and the rest, which is 100 minus 68.27, would be equally dispersed onto the left and the right, such that the total number of defects, if I have 100 such amount of goods which I am picking up, would be 100 minus 68.7 divided by 2. Why 2? Because there would be some goods whose specification would be less than mu minus sigma, and some of the goods specifications would be mu plus sigma onto the right. In case if I basically want to increase the level of confidence or level of tolerance, so I am using these words interchangeably, so they would become more clear as you read the book, go through the notes or go through the lectures. So, if I go minus 2 sigma onto the left and plus 2 sigma onto the right, then the overall coverage in that bandwidth of mu minus 2 sigma and mu plus 2 sigma, the overall area comes out to be about 95.45. So, the number of defects which specifications which is mu minus 2 sigma less than that and mu plus sigma and greater than that would be now 100 minus 95.45 divided by 2. So, you can basically find it out. And if I go to 3 sigma plus minus 3 sigma plus minus 4 sigma plus minus 5 sigma, what I am reading is basically the first column here plus minus 6 sigma, then the corresponding percentage inside the specification level basically increases from 99.73, 99.9937, then 99.999943, and the last value is 99.9999998. Now, if I translate onto the parts per million defect, then the values which are there on the rightmost column would give you some understanding that how the concept of sig sigma and its specifications gives us the overall number of defects based on the sampling which you are doing, also based on the fact what is the level of confidence of number of defects I want to have in a particular number of such drawings which I am making, like picking up those things. So, in that case parts per million defective for the case when it is plus minus sigma, it is 31,317,300. So, out of million. So, this would be basically the defects, and if I go to plus minus 6 sigma, which is the last value, it will come out to be about 0.002, which is almost 0. So, based on the level, so it has nothing to do with how you are going to achieve that. Obviously, it will mean that you want to basically tighten up the vendor supply quality, you want to basically tighten up the type of machining concepts you are going to use, you are going to basically give training to your workmanship, you are basically going to use a better coolant when you are doing the processing and the grinding machine, you will basically have a good jigs and fixtures, you will basically have a good environment, give a good training to the workman, so on and so forth. So, there would be 1001 things based on which you can increase the overall quality, but when you basically bring into the actual implementation stage, then you will find out the number of defects based on what is the overall specifications would be based on the fact which I have just stated. So, continuing the sigma discussion, Six Sigma discussion, the probability of producing a product within this specification is about 0.9973, which transforms to about 2700 defects parts per million. This is the concept of 3 sigma quality performance as I mentioned. Consider, which means that if you consider a product which has 1000 components of above type, and so for it to work correctly all 100 must function correctly. So, if I am basically so the probability that if there are 100 such products and if all of them are working based on the fact that the level of confidence of defects being there or not being there is being guided by plus minus 3 sigma, that means I am saying that plus minus 3 sigma deviation would basically have good products, anything outside the range is a bad product, defective product. So, the probability that a particular product is non-defective from that baskets, if there are such 100 such components, would be the case that the level of confidence which I can say, or the chances that the product would be particularly good is about 99.73 percentage. So, each being good would be 99.73 multiplied 100 number of times. So, it basically comes out to be 0.7361. So, the probability that the product will be defective, if I find out from that overall group which is 100 products, would be 1 minus 76.31. So, it basically comes out to about 23% or 24%, take about. So, I am not considering the decimal basis, I am just saying that if there are there are such 100 products, level of confidence for each being 99.73. So, the overall probability that the defects will not be there in those 100 products individually would comes out to be about 76%, which is 76.31, and hence the probability that there is some defective product would come out to be about 24%. So, now consider the fact that for a car which is about 100,000, which is 1 lakh components, or an airline which is about 1 to 2 million components, hence the corresponding probability would be calculated accordingly. So, again coming back to this, the graph which is the standard normal deviate, and if you see it, I basically have, or I have utilized the figure 1.12 again from Montgomery book, and if you remember, I did mention time and again, and I am going to mention in time and again, we are following this book as the basis for which we have basically designed the course and the lectures are being developed. So, in this case, if I consider the deviation of the mean value corresponding to the fact that it can go either onto the right or the left based on the fact that that sigma value would be considered as an input of corresponding to the deviation. So, it would mean that the corresponding specifications are giving along the first column, the percentage inside the specifications based on the fact that the mean value can be either shifted onto the left or the right is given starting from 30.23 till to about 99.999660, and the parts per million defective also can be calculated, and the values I am basically reading the first value and the last value are given by 697700 till the value of about 3.4. So, which means that reduce the variability in the process, so that the specification limits are at least 6 standard deviations or 6 total 3 plus 3 and minus 3 fluctuation onto the right on the left from the mean. Under such a scenario, the probability that the item is non-defective would be given to about 0.2 in ppm, which is parts per million. It is assumed that once 6 sigma levels is reached, the process may shift by minus 1.5 sigmas onto the left and the right. So, based on this we can basically do your calculations and then try to bring the process in that bounds as that you are able to calculate what is the number of defects parts per million or per thousand or per lakhs, based on which you can do your calculation and find out that increasing and decreasing level of confidence of good items, basically what is the overall percentage of good or bad items which you have within that the level of confidence which you want to have. But one should basically remember that if you are being more and more stringent, which is good, there would be a cost. Cost means on the negative side, that means if you are to basically trying to give a training which you are trying to increase the vendor quality, if you are trying to get good raw materials for which cost would be higher, if you want to basically have a process utilizing very good machineries. So, all this basically would have a huge amount of cost, but you should ask your question that whether if this cost is there, and when if you try to implement then from the concept of quality, whether that is compensated by the overall good quality which you are getting. So, if it is, obviously you will take a very judicious decision, but if you consider the overall philosophy based on which I started the course, it means that quality is basically an continuous improvement, and your main emphasis is basically to improve the quality in such a way that it becomes part and parcel of your thinking process, of your philosophy, how you do your work on a daily basis. So, the first point which I may mention, that how you balance the cost is basically from a very practical point of view, whether those amount of effort is actually needed from your end, considering the overall improvement which you can have on the type of vendors, type of raw materials, type of training, so on and so forth, cannot be increased after a certain value. So, if that is the case, whether it is really worth, so you have to make a decision. But having said that, I will again come back to my first initial philosophy when we started the course, is that quality has to be inbuilt in whatever work you try to do. So, 6 sigma is used for improving, continuing the concept of 6 sigma. 6 sigma is used for improving corporate businesses performance by improving quality and lowering the cost. Individuals using special training on statistical methods and quality management improvement tools are to be involved and should be utilized in order to implement the Six Sigma quality improvements. So, basically we see nowadays they are designated as green belt, black belt, master black belt. Basically these are people who have the training such that they incorporate the concept of statistical process control, how it can be brought into the picture and implemented on the shop floor for services, for manufacturing goods, whatever it is. So, now we will basically go into more of understanding in the qualitative sense about concept of quality. So, we will basically define the 5 so called concept, which is define, measure, analyze, improve and control in an overall sense about the concept of quality, which is known as the DMAX step, which is the 5-step problem used in problem solving approach. So, first is define the opportunities. I will just read or and explain the first few bullet points and then basically try to explain that in further details as per the discussion what is needed for this course. The second would be measure the performance. Third is analyze the opportunities based on which you are trying to do your business. Then you will try to basically improve the performance of your production of your services, whatever you are trying to deliver to your customer. Then you will have a control performance concept, we will try to basically analyze that what the control things you want to implement in order to implement that concept of quality for the overall production and the service concepts. So, the objectives are basically the bullet points: identify and or validate the business improvement opportunities which are there for you. So, if you think that costs are decreasing for the raw materials, so rather than basically trying to pass on the overall profit to yourself by not decreasing the overall selling price of that product, you should basically aim, even though it definitely may not have any immediate implication for your quality, you will basically try to share the overall the profit between the customers and yourself. But having said that, obviously this concept of lowering of raw material cost and lowering of overall cost which you are having would also be implementable for the other competitors who are selling the same type of product. So, in order to basically have an understanding that how you will basically improve the overall process, you will try to implement in a very finer points the concept of quality and how quality can be improved. Like say for example, you will try to increase the overall level of competence of the workers by trying to basically take the overall profit, breaking it between the customer and yourself, you will try to basically pass on to the customer utilizing a training concept for your workmanship. Or say for example, you will try to basically improve the overall level of training which the vendor should have. Or say for example, if you think that you have the money, you will try to basically procure a good machine to do the work. Or say for example, you will basically pay more attention in trying to basically improve the overall supply chain management system which is there with your end. So, with this I will basically stop here for the 7th lecture and continue with these slides which are basically the 5-step problem solving approach, and then discuss about the concept of quality in more detail in the 8th and 9th lecture, and build up the concepts as that it can be implementable, and we can use the concept of quantitative techniques to understand how quality can be implementable. Thank you very much and have a nice day.